All right, we are moving on with our virtual notes today. So today you're covering topic number 10, elements, and then you can fill in today's date based on your A day or B day. So again, topic number 10, elements, and today's date in your table of contents. And then we need to move to the next available page on the right-hand side. I know we're probably tired of hearing that by now. Next available page, right-hand side at the top. Elements, topic number 10, today's date. And question number 1, what is an element? So an element's probably a word that you've heard before, and you're probably familiar with some basic elements already. So an element is a pure substance. It cannot be changed into a more simple form. It's composed of only one type of atom. So things like iron, gold, silver, copper, calcium, nitrogen, these are all elements. They're in their most basic, simple state. They can't be made any smaller. They can't be made any simpler. There's nothing to break down or take out. It's in its smallest form already. So you can see like this is an atom of nitrogen. So this is what nitrogen would look like. This is just a cute little fun video, which I will share the link with you. So an element, we need to write this down, is a pure substance, cannot be changed into a more simple form, and is composed of one type of atom. That's going to be really important.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium.
So I'll share the link with you and you can finish watching the video. If you can recite the whole periodic table, I'll definitely give you some extra credit. So question number 2, what do we know about these elements? And this is really important. So I would draw this little square right here and fill in this information with me. So we have like an element block. We have helium. So I would fill in all this information because this little number right here, and I'm not going to specify that it's at the top, but this little number is what we call the atomic number. You have your element symbol and the element name, and then the larger number, usually with a decimal, is the atomic mass. So the important thing to remember here is that the smaller number is always going to be the atomic number. The larger number, even if this was a 2 with a decimal, the larger number is going to be the atomic mass. And then I wrote you a key note down here at the bottom. The periodic table is arranged by increasing atomic number. I can't say that enough. That'll be on every assessment you see from this day forward. The periodic table is arranged by increasing atomic number. And that's going to be was at this point up here at the top. I didn't want to specify small number at the top because it's not always located at the top. So no matter if it looks like this and one's in an opposite corner, if the small it's on the bottom, if you see it any of these different ways, we just know that it's a smaller whole number is going to be your atomic number, and a larger number with or without a decimal, but usually with a decimal, is going to be your atomic mass. That is key information. Question number 3. What does the atomic mass and the atomic number mean? This is why these numbers are important. So this right here is a model of helium, and I would definitely recommend drawing this, make it look identical to mine. So we have protons, neutrons, and electrons, and you can see I noted them by color and by signs over here. So electrons are on the outside, protons and neutrons are on the inside. So what does that have to do with the atomic number and the atomic mass? Well, how we find these numbers is based on the atomic number and the atomic mass.